Dynamic Group is an injection molder manufacturing medical devices and other precision products. The Minnesota-based contract manufacturer has installed 3 universal robots to handle repetitive tasks in injection molding and packaging applications.
One of the main reasons we needed to look towards automation was difficulty with staffing. We're lucky enough to live in a place that has high wages and low unemployment, which is great on a daily basis normally, but it's difficult as someone who runs a business. We went from having 3 operators on a single shift, getting about 40% of their hours in to make parts, to 1 operator per shift on every shift. So we essentially quadrupled our production capacity, and our scrap rate went from significantly high to near zero. For us to be able to have that type of success out of the gate, first times rookies at this stuff, was phenomenal and totally unexpected. What we found was the Universal Robot UR10 was to have a perfectly consistent cycle again and again and again. The first application we looked at was for difficult to manufacture medical connector. We make 2 different components in 2 different colors. A third component, they get all put together. The challenges for this product was the number of steps, the extremely heat-sensitive material, which made uptime difficult to achieve, and the amount of labor. The number of steps that we were able to eliminate made this work. The robot, when it initiates the cycle, we call them book frames that hold the components that need to be overmolded, is rotated to the back of the press where the injection molding process happens. When that's done, it rotates back around to the front of the press. The robot picks up those molded parts, transports them to a trimming fixture that also removes the parts off of the book frame. The robot picks that back up, places it on the table directly in front of an operator where they can pick up the book frame and reload it for the next cycle. Once they've reloaded it for the next cycle, they place it on a tray. The robot comes and picks it up, puts it back into the injection molding press. Once that's complete, it reactivates the cycle again. For our medical kitting application, the first thing the robot does is it picks up the bottom of a clamshell. The second thing it does is it uses vacuum to pick up 2 sterile wipes along with some saline solution and places those into that clamshell. Once it's done that, it slides the full clamshell onto a conveyor and repeats the cycle. Previously, we used 6 to 7 employees at once to do the kitting application, and very fast pace and very high volume. It wasn't sustainable. So now we're able to run it with as little as 2 people. Our third application uses actually a traditional Cartesian robot, and there's a handoff to our UR. It was a very challenging operation for the operator to keep up, making sure the parts didn't fall and trimming them as well. Now we still use 1 operator, but they can be there 1/4 of the time they could otherwise. The UR does a great job of grabbing those parts from the Cartesian, getting the gates trimmed, and palletizing them, ready for an operator to quickly inspect and package. When we first started looking into automation, I was surprised to find that we could afford a 6-axis robot and a collaborative one at that. I assumed those systems cost hundreds of thousands of dollars. The return on investment on our initial system was less than 2 months. So my initial assumptions of hundreds of thousands of dollars and extra hires was completely wrong.
The programming was rather simple. It was the first time I've ever dealt with the collaborative robot, so it took about 2 days for me to actually figure it out and get everything programmed. When you push the button on the teach pendant, you can grab the end of arm and move it to whatever position you want, and then once you release it, you can save the position and teach it as a point. It made it a lot faster and easier to program that way.
We're able to quickly redeploy these robots to completely new tasks in very short order. We have all of it on bases that we can transport around on wheels and slide them from press to press and application to application. That's been hugely beneficial to us. We're looking at being able to install robots directly on presses. They're small enough and light enough, and with quick tool changes, we should be able to address our high mix, low volume situation extremely well. So the safety of our employees was very important. We are working directly with the robot. There is no fence in between. I asked our partners, Bros, to show me how the safety system works, and we wrote up a program that allowed me to walk in its way as it swang back and forth. I was pleasantly surprised. It didn't hurt, and it sensed me immediately and stopped, just like I'd want it to. When there is a safety stop, the operators are able to look at the screen without any assistance from a programmer or an engineer, interact 2 quick buttons, so uptime's fantastic with these systems. When we were getting ready to put automation in, we spent some time preparing people to communicate with them that it's not here to take their jobs, that it's going to give them a better job to do.
When I was younger, I'd see, we started seeing robots, pop up, in the 90s and stuff, and I never would have believed that I get to work with robots one day. I think it's awesome. My work was a little bit more strenuous without the robot, but now that we've got it, I mean, it's made my days go by a lot easier, faster, and it seems like it's made everything run more smoothly. It's the future. I mean, what a time to be alive, I mean.